Hello, welcome back to China Manufacturing Decoded. It's the podcast from Sofeast, and we're glad to have you along. And it's not only myself, Adrian, from the team here. I'm joined by our CEO, Renaud. Hi.
Hello. Hi, Adrian.
And also Paul Adams, who is one of our senior engineers as well. Hi, Paul.
Hello there. How are you doing?
Yeah, good. Thank you. Hope you guys are okay as well. And all of the listeners too. We've just gone into March, so I guess it's spring now. So I'm looking forward to some better weather at least. Let's keep our fingers crossed for that, right?
Yes, indeed. We'll be good. About time.
Yeah. Unless you're in the Southern Hemisphere, in which case, lucky you, and definitely jealous from up here in Europe. But yeah. Okay, so today's topic, it's episode 152, by the way, is why assembly fixtures are important for productivity and quality. So looking into different kinds of fixtures, actually we'll also talk a little bit about checking fixtures as well, as they are not exactly the same, and that will come on later in the podcast. So to kick it off, let's examine what assembly fixtures are and what role they play in production, please.
Basically, when we're talking about fixtures, a lot of people sort of mix up the term jigs and fixtures. Well, we're going to be focusing on fixtures today, and this is basically a guide. Okay, so we're going to be focusing on how a fixture can benefit you and how they're basically used in manufacturing and an assembly line. Now, the definition of a fixture is basically it's a device that allows you to make a placement of a component or components accurately and correctly. And this actually allows you to put things together faster. It saves time from an assembly aspect because there are no errors or issues putting components together. So basically, this is a fixture that allows you, or it's a guide, and it gives you guidance to put components together. Now, fixtures to do testing, we'll come on to that a little bit later on. But so basically, this is what a fixture is all about.
Right. Well, a lot of people, who are not very familiar with production might think, assembly is like you have a Lego kit, and then you put it together, or maybe an IKEA chair or something like that, right? Piece of furniture from IKEA, you have the work instructions, and you have a few tools and a few screws and whatever, tuk, and it's up and you've done the job, right? Now, when a product is industrialized, is to be made on a large scale, very, very, very often, there's all kinds of little types of tooling, and that includes fixtures and jigs and whatnot. And here we're focusing on just fixtures, just keeping the product or a part of the product in place when then the operator or the machine is going to do something onto it, right? It's not just a Lego set, right? And it's not just for assembly, by the way. For example, an example that everybody can kind of picture is, what a frame, a glass, eyewear frame looks like, right? And a lot of them are in plastic, and it's usually in acetate kind of plastic, right? And so you get the front part, right, with the two big holes for the glasses themselves, right? And then on the side you have the temples, right? And they're connected by a hinge. Okay, now that hinge, how is it connected to the two parts? Okay. Is it just with little screws and things like that? No, actually the temple, so that part of the frame that goes over your ear, usually, or in many cases, the hinge actually is sort of inserted like a knife into the center of the temple. Okay. And that's how it's really sturdy, keeps it in place, it doesn't really move. Okay. Well, how is that kind of knife, if you want, inserted in the middle of the temple, always the same way, always the right way? Well, you absolutely have to have a fixture, right? You gotta have the temper, so that part of the frame kept in place, put in a certain place, kept in place, kept exactly in the same direction, the same position, and then there's like an arm that pushes the knife into it, always precisely the same way. Okay, if you don't have a fixture here, well, good luck doing that. Okay, like every time, sort of like a craftsman. I'm going to, like, am I kind of centered here, and I'm going to punch, and I'm going to see if I missed, or if the pot moved a little bit. If you do that, you have a very high rate of quality issues, right? Plus, you also need a very skilled craftsman to always try to target and punch it in the right place. So it's more expensive, and it's also slower because they have to adjust and target and so on, right? And rework and so on and so forth. So I was trying to find a simple example that people can imagine based on everyday products, but there's a lot of other examples like this, right? It's basically every time you have someone sort of maybe fumbling on their operation, needing to adjust and with a lot of defects or very slow, usually, okay, that part of the assembly, there's a problem. We need to do something. And in a lot of cases, okay, let's do a fixture, right?
I think the example that you've given, I mean, not using that fixture, then it sounds like you would be using a process that is exactly the opposite of mass production. A craftsman who does everything one at a time, and it's slow. This is absolutely not what we're looking for. So yeah, that's one good example, and I hope that we get a few more as we go along as well.
I just want to say that is a really good example, because you can imagine the size of the components that you're trying to assemble, and if you're trying to do that manually, with a pair of tweezers or a small pair of delicate pliers or something, it's super, super difficult. And as Renaud said, the chance of getting errors is exponential. It's just really, really difficult without that fixture in place.
Yeah. So another example, and it's always tough on a podcast, people are kind of listening and trying to picture things in their mind, but imagine a dog collar or a cat collar. Okay. Sometimes we do these kinds of assemblies, and there's a kind of sort of like a key ring, if you want, or some kind of spring, right? So imagine you have to open a key ring, I don't know, 500 times a day to insert something into it and place it the right way and so on. Manually, you're going to be tired of it pretty fast, right? And you're going to use your nails, you're going to use, you're going to fumble, it's going to be a bit difficult. Well, just by having a simple assembly that keeps it in place and with something else that makes it very easy to open once it's kept in place, you do that operation maybe 8 or 10 times faster, and it's so much more comfortable for the operator. And when the operator is doing it in a comfortable way, then it's repeatable, it's not stressful, it's much higher quality, much higher pace of much higher number of products made in a day, much faster. In some cases, there's also safety issues or ergonomic issues that you want to avoid, right? So basically, you improve the process, right? I think what's the name of that very famous Japanese industry engineer, Shigeo Shingo, right? He said, make it better, faster, cheaper, but in that order, right? And really, the idea is that if you try to reduce quality issues, basically to make your product better by looking at the process, you're going to come up with a lot of these little things that really bring the product from craftsman, skilled craftsman, to repeatable industrial operations, and to make it, always consistently good. And if you do that, if you make it consistently good, then you are going to not only have better quality, but also you're gonna cut your cost a lot, because the same person can do a lot more of these operations, in the day, right? So it's also going to be faster. It's also going to be cheaper, right? So that's the best, when you can improve the process in a way that at the same time makes everything faster, makes it cheaper, makes it better. I mean, what's not to love, right? And that's why process engineers are tasked with thinking of, what kind of fixtures can be used to make that assembly, not just assembly, by the way, also packaging and so on. How to make that process easier? How to just assist the people in doing a better job, right? So that's the whole idea here.
You've kind of already covered the benefits. So just to sort of recap, we're talking about improved productivity, improved quality, reduced costs, and consistent production as well. For example, with complex parts with tight tolerances. And anybody that is trying to mass produce a product, and by mass production, we're not necessarily talking millions, but we're also talking much more than just a craftsman making, a few pieces a week or something.
Yeah.
They're going to love these benefits, right, of assembly fixtures.
Yes. And maybe, Paul, do you want to explain a little bit the concept of mistake proofing? Because sometimes some really good fixtures also mistake proof the operation, right?
Well, that's a true statement. And so a lot of people get confused with respect to having a great design. If I design the product brilliantly, correctly, and I've got a fantastic design, nothing can go wrong. Well, that's not necessarily the case. And we have to be smart with respect to our designs. From a design aspect, we need to make sure we've got an error-proof design. In other words, you can't put the thing or the two components together back to front and cause an error. So, there's a term, Japanese have got a term they've coined, which is poka-yoke, which is basically translates into error proofing. And one easy thing to do this is to design a product that's is different size components. Say sort of 3-pin plug, for example, that's used in the UK, Adrian, where you are based. There's no way that you can put that 3-pin plug into the wall, the electrical outlet socket, incorrectly. You just can't do it. And that's a very, very obvious way of designing a product. However, when it comes to the opportunity to introduce fixtures to do the same, you could actually design a fixture that allows you to prevent components going together incorrectly. So for example, you've got take the 3-pin plug, for example, but take something similar where you've got an offset pin orientation and you've got a set of holes in the other component. You could blank off one of those holes with a fixture such that the mating part only goes into the correct pins. So that's one sort of blanking off areas, stopping a component being assembled in one particular orientation through the fixture and the way that's located in the assembly itself. That's a great way of using fixtures for ease of assembly and stopping this component issue where they're assembled incorrectly. And that can be done. Assembling something upside down. It's a very, very simple mistake to do. But if you've got a fixture on there that prevents you to doing that somehow, then we need to look at that from a design aspect and get that made.
I've done it with IKEA furniture many a time.
Easily done.
Assembled it the wrong way up.
Because with the IKEA or the flat pack products, wherever they're coming from, you're not going to get these fixtures. But we have the benefit on the assembly line to actually have a look at that and say, okay, there's a potential error here that could happen because there is no design feature in the product that allows that to, prevention of assembly. So we have to design something and put a fixture in place to prevent that error occurring.
Yeah, talking about furniture assembly. I mean, furniture, especially wood furniture, there's a lot of drilling, right? And then very, very common, when you drill, you get to have a fixture, right? To keep the part in place, and then it gets, the drill bit goes into it. So there's got to be a fixture. The fixture is already there. I mean, you can't really do it without a fixture, or the part is just going to go spin around, right? But if you allow the operator to put the part, as you say, maybe upside down or whatever, wrong orientation, then, hey, if he does it 10,000 times, there's going to be mistakes, right? 5 times in a row, maybe it's going to be all good, but 10,000 pieces in a row, I'm not sure, right? So then you have a pin or something that actually makes it impossible to assemble the wrong way. And to get back to what Paul was saying is that good design, sometimes all of these potential mistakes are already taken into account at the stage of product design, right? But it only goes so far. Right? So maybe you would have, and maybe like this, when you have a computer, one of these desktop computers, and you have this cable is green and this port is green, and I know I plug them together and things like that. Try to make things really sort of obvious, and that's in the product design. But then you still need to think of the process design very often, right? A good product design will actually include also good manufacturing process design, because you need both, basically. As soon as you have a not very simple product or a complex product, then you really need to work on the process. And in some cases, they do such an amazing job on to design for assembly that the assembly really is nearly like a Lego kit, right? So there's this classic example of the IBM Pro printer, it was called, in the 80s. That was in the 80s, the Pro printer. And there were much fewer parts than in most other printers. And it was so simple to assemble everything from top to bottom, clock, and everything assembled in 30 seconds with zero assembly, zero kind of fixture or any other tool. That's just amazing. But that's the extreme. That's when they push design for assembly to an extreme. They really push the envelope, right? In most of the cases, that's not the case. That just doesn't happen. It's not that simple, right? And that's why when you get to a final approved frozen prototype of the product, well, process engineers, industrial engineers, manufacturing engineers, whatever you call them, are going to have to work on that. Okay, how are we going to make that in a repeatable way, in an efficient way, right? And that's where they come up with fixtures, among other things. This really has to be developed, thought about before mass production begins. And typically, when the engineers put together the final set of prototypes, there should be a process engineer looking at it and doing it with them, and already pointing to some potential issues and already thinking about all of that. So that, it's not something that maybe you do all the prototyping on your side and then you send it to a supplier and they just take it and they run with it and they go into mass production, and it's just something that they will have to figure out. Now, if you want good, consistent quality and, sort of drama-free production, you need to start to think about it. And it's quite common for some of our customers to say, well, here and here, we kind of know that there's going to have to be some kind of fixtures, we leave it up to you to think about it, right? Okay, fine. But they already have an idea, and they should have an idea about where assembly is not going to be so easy, so straightforward, right? And that's a great way to cut costs, because again, you make a batch of 5,000 pieces. Well, maybe with a few smart fixtures, you you save maybe 45 seconds per piece or 1 minute per piece, and you also get the first pass yield way up. You take the quality rejects way down, right? And that's a lot of cost savings, right? So that's really, really important.
So you're talking about the time. You're talking kind of about the timeline here of when to actually start looking at this, and also talking about sort of assessing where and when fixtures might be required. And I think this is important information for importers because, as you mentioned, you could just leave it to your manufacturer, but that would perhaps be a bit of a deficient way of doing it that isn't going to get you the results that you want because it might be too late by then.
It depends. So if you do the product development, you have to start thinking about it, but maybe not designing the fixtures. And then it really depends on, the skills and experience of the manufacturer, I would say. I mean, Paul, what has been your experience on that?
No, I totally agree. I've been on both sides of the fence with respect to sort of design aspects. You've been working with a design team internally, and we really had to focus on getting production tack time. In other words, the amount of products out and the quality yield up as high as possible. And in order to do that, you really have to think outside of just the design itself and work with. Now, this is the important thing that I've experienced, work with the manufacturer and not against them with respect to understanding what their capability is, understanding what their knowledge and experience is on building and trying to identify various different fixtures in each of the stages of the manufacturing process itself. Now, what I've found is it's absolutely imperative that once we get to that stage of production, that at least a production design engineer or program manager or whatever from the business goes to the manufacturing plant, sits down with the engineers, sits down with the production line crew or the manager, and actually work through the steps one phase at a time, and actually try and identify and work with them what these fixtures are going to look like and how they're going to build them and implement them. Now, from a materials point of view, you may be sitting there thinking these fixtures, man, they sound super complicated. Well, they don't need to be. In some cases, they just could be a right angle with a couple of pieces of wood. Just so you're on a location aspect. Very, very simple. It could be sort of machined perspex, where you're putting something there. Very, very simple. Doesn't have to be, rocket science to make things so much better. The cost of some of these fixtures is next to nothing, but the result and the yield is through the roof. There's exponential gain from a very, very simple fixture that can be put in place.
Yes. Absolutely. And then let's say the fixtures are, they do require some engineering and fabricating them, maybe an outside motor fabrication, a tooling fabrication shop needs to be paid for that job and so on. Typically, who would pay for it? Who would own the fixtures? What makes sense in most cases?
Yeah, well, certainly talking about my experience of what I've done in the past, as an importer, I'm going to sit on the importer side now, as opposed to anyone else. I've always said that anything that we are designing and producing that is involved with the production of the product itself and improving the quality should be our ownership. So therefore, we would pay for that. Yeah. We would work with the design, and that would be the importers or the designer's property. And that would be part of their experience. However, so anything to go with the production line, if the production line is on rollers and skates and everything like this, and also moving conveyor belt and anything that is part of that assembly is clearly part of the contract manufacturer, and it's their responsibility and their cost.
Yeah.
But I think
so
from a
it's,
fixture point of view, I would say that it's really 9 times out of 10, the responsibility, ownership to design, pay for it, and own that fixture.
yeah, because the key point here is if you're going to switch from this manufacturer to another manufacturer, you want to make it very easy for you to transfer, these fixtures. Not
Very
have the
true.
new guys, have to reinvent all these things. No, you want them to benefit from the experience of the first one and so on. And you own these fixtures and you have the list of these fixtures and they are maintained the proper way and they are, maybe renewed every X thousands of pieces made and so on. This has to be managed. And then if you decide to transfer, you should have the right to pull all of that and transfer it to the new manufacturer, right? Yeah, but if it's the property of the manufacturer, then end of story, right? And then you're gonna have to have a manufacturer figure out everything again from scratch. Maybe you don't even have a video of the assembly work, going on, so they have no idea even what that process looked like. That's not what you want to do. Okay, you want to have some control here. You want to have some visibility, some control, as we always say, and this is really part of it.
Mm-hmm. Yeah, yet another deliverable that you need to get into that manufacturing agreement.
Yes.
Okay.
Yes.
Yes.
Yeah, it's all the tooling. It's part of all the tooling, basically.
Yeah, and say it's all part of the your asset list.
Okay, so we've spoken about assembly fixtures. You've given some great examples, and at the top of the show, we mentioned we were going to also talk about checking fixtures, which are similar but not the same. I think you'd agree. So these are fixtures that are more likely to be used in QC work, of course, because we are checking. So let's go into the checking fixtures then, Renaud.
Well, the idea basically is that you still take the product or the part and you put it into a fixture, and that fixture is going to help you determine if the product is okay. And a lot of that usually is dimensional. Okay. Not only it can be also function check and so on, like a full testing station, right? But a lot of these relatively simple examples are just going to tell you dimensionally, is it okay or not, right? Rather than having to keep the part in your hands and take a caliper, a micrometer, or whatever, right? Paul, would you have a few sort of examples or different kinds of checking fixtures?
Well, the obvious one, sort of building on what you were saying there, from a dimensional, the simplest check you can do on a production line, for example, is take the component and it's got a tolerance on the length, for example, and you've got a simple go, no-go gauge on the assembly place where you're actually doing that. So you pick up your component, you place it into the go, no gauge, which has got it's got the maximum, minimum dimension that is allowable. And if it's outside of that, it's going to be obvious. Either it won't fit in the gauge or it's going to fall through the gauge. It can't be used. Very, very simple. That's probably one of the simplest inline inspection checking fixtures we can think of, a go, no gauge. And another, I would say, relatively simple, because I've worked on this many, many times in the past. But can you imagine in the automotive industry, the wiring harness, how complex that is? Okay, so you've got plugs that go into left, right, and center, the front of the vehicle, the back of the vehicle, under the dash, everywhere. And if you got one of those wires that is not actually connected correctly, or the crimp on the pin is loose or is not secure as is put into the plug itself, if you put that wiring harness into a vehicle and then that vehicle doesn't start because you've got an electrical fault, where are you going to start? It's a fault finding nightmare. But one of the simplest things to do is you've got a fixture that lays out the loom. We call these the wiring harnesses or loom. And you basically plug in each of the plugs, right? And that will give you a continuity. Make sure you got A connects to A, B connects to B, and you'll get the signal. That can be a sounding signal, a light signal, or sort of whatever signal it is to say, yes, everything's working. Or more importantly, that this checking fixture allows you to identify the fault before you assemble a very complex wiring harness into a vehicle. Okay, so that's going.
So that's that's what we would call like a testing station, right? Does it function when you plug things in? Yeah, it's some kind of fixture, yeah.
It's a big fixture, but that's probably going to the other extreme than the go no go gauge.
Right. Yes, exactly. Yes.
Yeah, but when and again from a design aspect, if you're designing a product, you need to understand the critical stages throughout your product assembly. Okay, I've been working on some products recently that are, without giving too much away, they basically hold water, and they've got to hold water at a certain pressure. Okay, and some of these can be checked at a sub-assembly point of view. Okay, so what we're doing now is understanding the process of the assembly and where each of these critical components can be checked. Now, obviously, we don't want to be filling these components up with water and checking them under pressure on the assembly line. So the easiest thing to do is fill them up with air. And once you've got an airtight system, you can check very, very simply on a pressure gauge with a needle, whether that is holding air or whether we've got a leak somewhere. So we don't have to actually test live, in other words, with water, but it's a critical stage within the assembly itself. So that will be a very, very quick checking fixture where you plug in one end of the hose, plug in the other end, turn the lever, you've got air. Yes, it's holding pressure. Unplug. It's safe to assemble. We know we're good to go.
Interesting.
Right. Yeah, because you don't want, there's a lot of products that are supposed to contain water, but you don't want to test it with water because then how do you make sure it dries and all that kind of things, right? It's very common. Yes.
Yes, that's right. Yeah, you need to fill up the water. Once it's watertight, you need to empty it. You're going to dry it before you assemble it. It's very complex. So air is a very good process of checking whether a system is watertight or airtight in this case. So that's good. And another example I can think of that I've used in the past is where we're placing completed assemblies of printed circuit boards or PCBAs, printed circuit board assemblies. Okay, and you'll pick them up 9 times out of 10. You're wearing a protective gloves or a strap for EMC.
Electromagnetic compatibility. Yeah.
That's right. Yeah. So if you've got static built up on your body, you're going to potentially fry one of these ICs. So, but how do you know that PCB has not already been picked up by somebody who's not wearing the protective equipment? And they have actually, it's like put their static electricity onto the component and fry the IC before you actually get a chance to put it into the assembly. So another very, very quick and easy way is to put the PCB on a bed of nails, what we call a bed of nails. And basically all of this is a set of pins that are sprung loaded, and we call them pogo pins. You put them down, you then close the lid or push, which is pushed down. All of the key contact areas. Now, most PCBs have got test points on them. And it's easy to actually test whether that PCB is good or is bad before you assemble it.
ESD, electrostatic discharge.
That's the one. Well done, Renaud. We got there in the end. It's but again, it's like, can you imagine the cost of getting the product down the end of the line, and it's a relatively complex assembly, and you plug it in for final check and nothing works? The cost that goes into that assembly and the product is not good. So the thing is with it, all of these fixtures, whether it's checking, whether it's an assembly, is to reduce the amount of rejects going down the line.
I like it.
Yep. You catch the problems at the source or close to the source. Absolutely.
Yeah.
Okay.
Yeah. And like I said earlier, some of these fixtures could be as simple as anything. You know, if another very, very simple example is when I go and buy a light bulb over here where I live in Asia. You know, I can't just go and buy a light bulb off the shelf, right? The guys in the shop have to test it. You know, they don't screw it. They just pop it in. Yes, it lights up. So simple. It's so simple. Now, you could actually engage that type of technology into a test fixture on your production line, you know, such that you've got a bulb that comes on to show you your circuit is correct or it's working. If it doesn't come on, you've got a problem.
Good examples. Okay.
Yeah.
Well, I think that summarizes those fixtures really, really well. And I think it also shows the real importance of them, especially in the context of even if you've got a good design, it's not actually going to guarantee great assembly or quality during production either. So, and I think that's important for importers to remember, isn't it? So, when it comes to the investment as well, I think an interesting point was that in theory, this is not a cost which is going to be huge. I suppose engineering work is maybe going to be some of the more expensive costs for simple fixtures. Maybe very complex fixtures would be more costly. But when we are weighing up the cost of doing this against the cost of not doing it, there's a clear winner.
Yeah, right. Yeah. In most cases, the payback is like, you know, once you start mass production, the payback on it is a few hours. The ROI is just astronomical for sure. And a lot of them are very, very simple. But you have to think, basically, process engineers need to have seen that a number of times. And then they will say, okay, these guys are fumbling. This operation here is not so easy or whatever. Okay, what kind of little simple tooling could help them? Okay, this kind of fixture like this, they push it into that corner, then they do that, and then for sure it's so much easier. Okay, done, you know. And then from there they can go into next step, making it a little bit more advanced, and so on and so forth. But in many cases, you know, they have to be a bit creative, right? And they can do a lot with very little. That's the key idea here.
I think you're right. I just want to build on that sort of comment, Renaud, which is really good. And if we can look at both sides of the coin here from a design aspect, you know, it's your responsibility or our responsibility as designers to actually try and figure this out. But sometimes you just can't. And this is where having a pilot run, for example, would really, really be useful because, you know, you can actually run the product down the line with a couple of hundred components, you know, a couple of hundred sort of assemblies being built, and actually identify new areas that you would not necessarily have thought of during that design process. And this is an evolutionary process, by the way. You know, you could actually work on this time and time again and try and improve each of the assembly steps and processes over time. And you can do that through various different processes of studying time and motion and, you know, going down and just looking at each stage of the assembly and see where everything is absolutely singing beautifully. Or, you know, like we said in the past, if someone's stumbling or there's more faults at this particular stage, you need to understand why. And maybe it's something like a simple fixture can actually resolve all of these issues.
Yes. Yeah, exactly. I fully agree.
Great. Well, that rounds it off really nicely. Thanks, Renaud. Thanks, Paul. Good examples and a good illustration about the importance of fixtures. I've really enjoyed it. I think it's a fascinating discipline as well, how these guys can go into, you know, a factory, see the production line and just start thinking, their brains whirring and they're thinking, how do we make this better? That's just fascinating. So, yeah, I think interesting stuff for all the importers out there and everybody listening. So it's a good one, and we'll be back next week as normal. So thanks to you guys and thanks to all the listeners. Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.